Section 2.7 is about slope and equations of lines. So the slope of a line M is the ratio of the vertical change to the horizontal change between 2 points. And again, ratio can be written in fraction form. So when you're looking at the slope formula for M equals y1 minus y2, all divided by x1 minus x2. So again, that's a ratio because it's in fraction form. Okay, so you're going to be able to find the slope in two different ways. You can either use that formula, the slope formula, or you can count on the graph. So you can pick any 2 points on the line like they did here on the right-hand side. And the one thing that you just want to keep in mind is always move up or down first. It doesn't matter which point that you start at, but whatever point you start at, move up or down first, then left or right. So up or down is going to be your change in y. As you're moving up, the change in y is positive. As you move down, the change in y is negative. And for your change in x, as you move right and left, as you move to the right, x is positive, and when you move to the left, x is negative. So if I start at this left-hand point that I'll put an x on here, I'm first going to move up a total of 1, 2, 3, 4, and that's how they got their 4 there. And again, because I went up, it's positive, so that's why it's a positive 4 on the top. And then I went to the right, 1, 2, 3, and that's why there's the 3 on the bottom. So 4 over 3 is the slope of that line. So for the next example, we want to find the slope of the line determined by the 2 points. So again, I'm just going to count. I'm going to try to count because there's not really it's not as easy to count as there was the grid on the first example there, but we can try to count first and see if we can count and see what we get here. Okay, and then we'll do it with the slope formula just to make sure. Okay, so I'm going to start here this time. So let's see how far I have to go up. I'm going to have to go up 1, 2, 3, 4. So I'm going to go up 4, and then I'm going to have to go to the right 1, 2, 3, 4, 5, 6 it looks like, and I'll have to go to the right 6. So from the graph itself, it looks like the slope is going to be 4 over 6, and I'm just going to double check using the slope formula. So my two coordinates again are -2, -1, and 4, 3. I'm going to call this first one x1, y1, and the second one x2, y2. Okay, always x, y, ones have to stay together, twos have to stay together. So again, the slope formula is y1 minus y2 over x1 minus x2. And yes, you do need to memorize that formula. So above y1, we have a -1. Then you have this minus sign from the formula itself that I'm going to bring down, and y2 is 3. So I'm going to have -1 minus 3 on the top. And on the bottom, x1 is -2. Again, you have that minus from the formula that I'm going to pull down. And x2 is 4. So subtracting on the top, -1 minus 3 is -4. And on the bottom, -2 minus 4 is -6. And a -4 divided by a -6, a negative divided by a negative is really a positive. And again, you can see here that you got the same exact answer. Okay, and also, not only are you getting the same exact answer there, and if you write that on a test, it's fine, but on a Regents exam, on a test, if it's a multiple choice, you will never see 4 over 6 as the answer. They're going to reduce it into simplest form. So if I wanted to reduce 4 over 6, 2 goes into 4 twice and into 6 3 times. So the slope there is really going to be 2 over 3. So for number 2, I have the points 2, 3, and 5, 1. I don't have a graph grid here, so I'm not even going to try to graph them or anything like that. I'm just going to straight use my slope formula again. So again, since this is my first ordered pair, I'll call it x1, y1. Since this is my second ordered pair, I'll call that one x2, y2. Again, just to save a little room here, this is the slope formula. I'm not going to rewrite it. So y1 is 3, a minus sign from the formula, and y2 is 1. On the bottom, x1 is 2, a minus sign from the formula, and x2 is 5. So on the top, 3 minus 1 is 2, and on the bottom, 2 minus 5 will give me an answer of -3. So -2/3 is the slope of that line. Okay, one thing real quick, just to reiterate, because again, we're getting to fractions and slopes here. It doesn't matter where you write that negative sign. The way I have it written, it's in the bottom of my fraction. It would be the same exact thing if you wrote it in the top of the fraction, or if you wrote it right next to the divide sign. Same exact thing. All three of these are exactly the same. The only thing that you can't do is you can't make it -2 over -3. Because again, if they were both negative, a negative divided by a negative would end up being a positive. But any of these three ways are perfectly fine. So we're going to have two forms of a linear equation, and hopefully you remember both of these from algebra last year. So you're going to have something called the slope-intercept form. The name of the form tells you what you need. You need the slope and the intercept, the y-intercept that is. So the slope-intercept form is y equals mx plus b. Okay, this m, the coefficient of x, is your slope, and b is going to be your y-intercept. Okay, you always want regular old x and regular old y in the equation. So if I were to give you y equals 3x minus 5, and I wanted to know what the slope and the y-intercept are, the coefficient of x there, the slope, I know you can see it highlighted, but just to write it again, is 3. And your y-intercept, again, always take the sign that's in front of the number. That's going to be a -5. Okay, so when are you going to use this equation? It's used when given the slope and the y-intercept, or to graph the line. Okay, then the other form that you should have learned last year is something called the point slope form. So again, the name of the form tells you what you need to write the equation. You need a point and you need the slope. So the point slope form is y minus y1 equals m times x minus x1. And again, just like in the above form with the slope intercept form, that m is going to represent the slope, and this x1, y1 can be any point on the entire line. And just like above, when I said you want regular old y and regular old x in the equation, it's going to be the same thing here. We always want that regular old y and that regular old x in the equation. So it's going to be the y1 and the x1 that we're going to replace. And we're going to use this when you're given 1 or 2 points to write the equation of the line. Okay, so here's some examples. We want to write the equation of the line with a slope of 3 and a y-intercept of -4, Okay, so when you read that example again, you're given the slope and the intercept. So I'm going to use the slope-intercept form, which is y equals mx plus b. And again, the name of the form is what you're replacing. So I need the slope and I need the y-intercept. So I'm going to replace m and I'm going to replace b. So y is going to equal, m was 3, slope is 3, so 3x, and y-intercept is 4, so I'm going to have 3x minus 4. And that will be your final answer there. For number 4, I want to write the equation of the line with a slope of -3, and it passes through the point -2, -1. Okay, so this time I'm given a slope and a point. So instead of using the form that we used above, we're going to use the point slope form. And again, point slope, it's the one we tend not to remember the most. So every time that we use it, we'll write it down just so we remember. It's y minus y1 equals m times x minus x1. Okay. And the slope, that's the obvious part. I'm going to replace my m with -3. And this ordered pair over here is going to become x1, y1. So I'm going to have y, again, you have a minus sign from the formula, so I'm going to bring that down, and then y1 is -1. So you're going to have y minus -1 on the left, and that's going to equal, I'll take out that m, replace it with -3. And on the right, I'm going to have x minus, again from the formula, and x1 is -2. So I'm going to have x minus -2 inside those parentheses. Okay, we can clean this up a little bit. We don't like double signs when we're in this level math. So on the left-hand side, this double negative is going to become a positive. So we're going to have y plus 1. And on the right, we'll have -3. And again, same thing's going to happen there. The double negative will become a positive. So y plus 1 equals -3 times x plus 2 is going to be your final answer there. Okay, and then for number 5, we're going to have 2 different parts of the problem here. For number 5, we want to write the equation of the line that passes through the 2 given points. Okay, so what information are needed to write the equation of the line? Okay, I'm going to force us into doing the problem in one. I'll force you into doing A one way and B the other way. So in part A, let's put this one in slope intercept form, and let's put part B in point slope form. Okay, just because it doesn't say. Okay, so for part A, what pieces of information are needed to write the equation of the line? Comes from the name of the form. You need the slope and the y-intercept. Right now I'm given 2 points. I don't have the slope and I don't have the y-intercept. However, I do know what the slope formula is. So I can find the slope of this line by using the slope formula since I have 2 points. So the slope formula, again, is going to be y1 minus y2 over x1 minus x2. So I am just going to label this one x1, y1, and this one x2, y2. So we plug into that slope formula. Y1 is 1. We have a minus sign from the formula. Y2 is 7. And on the bottom, x1 is 3. We have a minus sign from the formula. And x2 is 9. So I'm going to have on the top 1 minus 7 is going to be a negative 6. And on the bottom, 3 minus 9 is also a negative 6. And again, if I can divide, I'm going to divide. If you can't divide, like we couldn't divide 2 divided by 3. 2 is not divisible by 3 in that earlier example. Don't. But here we can. So your slope here is going to be 1. Okay. So right now I have my value of m. But again, if I'm writing this in slope-intercept form, I need 2 pieces of information. I need the slope and I need the y-intercept. So now I have the slope. So now I have to go back and find the y-intercept. Well, there's only one thing that you know that has the y-intercept in it, and that's the slope-intercept form of a line, which is y equals mx plus b. So now what I'm going to do is I'm going to replace my y, my m, and my x in order to solve for b. What am I going to replace m with? This one that I just found above. What am I going to replace x and y with? It 100% does not matter which ordered pair that you choose. You can plug in 3, 1, or you can plug in 9, 7. It's completely up to you. I'm going to plug in 3, 1. And be careful, because remember, x comes first here, y is second. So when I go to replace y, make sure you're putting in 1 on the y side. So I'm going to have 1 equals, m also happened to be 1, and now x is 3 plus b. And now we'll solve that. 1 times 3 is just going to be 3, so I'm going to have 1 equals 3 plus b, and when I subtract 3 from both sides, b will end up giving me an answer of negative 2. Okay, again, well, that's great. Now I have a slope and a y-intercept, but I still haven't actually written the equation of the line. That'll be my last step. Again, y equals mx plus b. Oops, I forgot the plus sign there. Y equals mx plus b is the form of that line, and I'm going to replace the slope and the y-intercept. So y equals 1x minus 2, and you don't really have to write the 1. Y equals x minus 2 is exactly the same thing. And that is the slope-intercept form for part A. For part B, we're going to do the point slope form. I think as long as you can get used to that point slope form, it's always easier. It's always harder to do y equals mx plus b, but I feel like it's the one that that's been ingrained in your head last year, probably in 8th grade, whatever. But if you can learn that point slope form, it's so much easier. So point slope form again is going to be y minus y1 equals m times x minus x1. Again, the 2 things that you need a point and you need the slope. Well, the good thing is I'm given 2 points, so I already have the point part down. So the other piece of information that I'm going to need is I'm going to need my slope. So that we are going to have to do exactly the same way that we did in part A. So slope, again, is y1 minus y2 over x1 minus x2. So again, I'll go back up to my ordered pairs. I'm going to call this x1, y1, and I'll call this one x2, y2. So y1 is 2. Minus sign from the formula, y2 is 14, and on the bottom, x1 is 1, and minus sign from the formula, and x2 is 10. On the top, 2 minus 14 should give you an answer of negative 12, and on the bottom, 1 minus 10 is going to be negative 9. I'll clean that up a little bit. Okay, a negative divided by a negative is going to give me a positive, and 3 goes into both 12 and 9. So 3 goes into 12 4 times, and 3 goes into 9 3 times. So the slope of that line is going to be 4 over 3. Okay, and now again, you're going to pick which ordered pair that you want to use. If I use x1, y1, and you use x2, y2, the equations are going to look drastically different, although they're going to be exactly the same. So it does not matter. I tend to always use x1, y1. So I'll use x1, y1. Okay, so again, we're keeping this regular old y, this regular old x, we're replacing everything else. So I'm going to have y minus from the formula, y1 is 2, equals the slope we just found is 4 over 3, times we're keeping that regular old x and bring down that minus sign from the formula again, and x1 is 1. So y minus 2 equals 4/3 times x minus 1. Okay, and again, if you use the other one, it would end up looking like y minus 14 equals 4/3 times x minus 10. And again, even though those seem drastically different, they're exactly the same. And then for our last problem here, it says, which of the following is the equation of the line with a slope of negative 5 over 3 and passes through the point negative 3, 1? Okay, so again, you can do a couple different things here. It's completely up to you. All of these are in y equals mx plus b form, all of your choices. But on the top, I see that I'm given the slope and a point. So I think what I'm going to do is I'm going to write the equation of the line from the given information in point slope form. And then I'm going to transform that into y equals mx plus b form. Okay, so y minus y1 equals m times x minus x1. So this is going to be x1, y1, and obviously that will be my slope. So I'm going to have y, I have a minus from the formula, and y1 is 1. We're told that the slope is negative 5/3, and I'm going to have x minus from the formula, and x1 is a negative 3. Okay, so the only thing that I can really clean up a little bit here before I start transforming, I'm just going to make this double negative a positive real quick and then go from there. So y minus 1 equals negative 5/3 times x plus 3. Okay. The first thing I'm going to do, my goal is to get y all by itself, but on the right-hand side, I want to break down those parentheses because you see all of your choices, none of them have parentheses on the right-hand side. So I'm going to distribute that 5/3 through. So the negative 5/3 through. So negative 5/3 times x is going to stay as negative 5/3 x. Negative times a positive is going to give me a negative. And when I multiply 5 over 3 times 3 over 1, it should just give me an answer of 5. Okay, you can actually do that in your calculator too if you want to. And on the right-hand side, I'm going to have that y. Sorry, the left-hand side, I'm going to have the y minus 1. The only other thing that I need to do here in order to get y by itself is going to be to add 1 to both sides. And those will cancel. So I'm going to have y equals negative 5/3 x, and negative 5 plus 1 is going to give me a negative 4. So now all I have to do is go back up to my choices and see which one of them matches. Just be really careful of your signs. Negative 5/3 x minus 4 is going to be choice B.